Welcome back for round two. We're going to talk very briefly here about one-sided limits and the step function. One-sided limits, which we've discussed already, but we're going to apply it to a special function called a step function. One-sided limits and step functions. Step functions you guys have all seen at some point, maybe not heard them called step functions before, I don't know. The most common example of a step function is the greatest integer function. And the greatest integer function is kind of like a bracket, but it's kind of like a double score bracket. All right, it's got that little funky line in there. That is the greatest integer function, or GIF. Okay, the greatest integer function, what that does is it outputs the greatest integer less than or equal to the value that you put in. Example, the greatest integer of 2.7. In other words, the greatest integer less than or equal to 2.7 is 2. The greatest integer less than or equal to 3 is 3. The greatest integer less than or equal to negative 4.2, be careful, greatest integer less than or equal is negative 5, right? You go to the left for less than. All right, so let's look at what this graph will look like then. So as I take values between 0 and 1, the greatest integer less than 0 and 1 values, less than values between 0 and 1 is 0. So when I put 0 in, that's nor equal to, I get 0. But between 0 and 1, I'm getting values 0 to 1. Open circle at 1. When I put numbers like 1.2, 1.3, 1.9 in, excuse that bell, it's not time to go really. When I put numbers like 1.2 or 1.3 or 1.5 in there, the greatest integer less than or equal to them is 1. So we look like that. Now when I put numbers between 2 and 3 in there, well, when I put 2 in, I get 2, right? Greatest integer less than or equal. When I put 2.1, excuse me, when I put 2.1 in there, I also get 2. When I put 2.9 in there, I also get 2. 2.999999999, still 2. Okay, so you get the idea of what this function is looking like and why it's called a step function. Okay, here is a step function. Again, negative 0.4 becomes negative 1, so this continues the pattern down here. Closed on the left, open on the right. Okay, so there is our step function. And I hope it's clear why we only have one-sided limits now. So the limit as x approaches 3 from the right-hand side of the greatest integer of x. So as I approach 3, 1, 2, 3, from the left-hand side, my value, oops, this says right-hand side. As I approach 3 from the right-hand side, my value is up here at 3. But as I approach 3 from the left-hand side, so I'm coming from the left towards 3, I have a value of 2. Because when I'm approaching 3 from the left, I'm talking about numbers smaller than 3. So the greatest integer less than or equal to numbers between 2 and 3 is 2. But the greatest integer less than or equal to numbers between 3 and 4 is 3. Okay, so the one-sided limits conflict, which means the limit itself doesn't exist, but the one-sided limits are unique and can help us with continuity on closed intervals and things of that nature. So step functions are great for talking about one-sided limits, and there's an example of the greatest integer function of x. That's all I got for you today. Have a good one.